Hello, Mr. Ryan, you alright? Yeah. Okay, so today we talk about Cartesian product. We talked about that, mentioned that a few times ago. Cartesian product is the mathematic concept. Okay, so it's used on the set. Alright, in Python we have set, right? So look, A is a set, Cartesian product B. What do we get? It's a set, yeah. So A, B, tuple, right? And A is belongs to A and B is belongs to B. Yeah, that's what it is. Let's take a look at a very simple example. A if it's a set of 1, 2. B if it's a set of 3, 4. So A Cartesian product B. So we take one element from the first set and then we can do this all combination of the other sets. So it's 1, 3, 1, 4, and then 2, 3, 2, 4. Okay, now your turn. How about A is 1, 2, 3, B is 4, 5. So A Cartesian product times D.
1, 4, 1, 5, 2, 4, 2, 5, 3, 4, 3, 5.
Yeah, exactly. Okay, you got it, yeah? Okay, so this is Cartesian product. In Python, we can from editor import product. We use this product from the editor. So let's take a look at this example. Okay? So look, in Python, okay, let's say A equals 1, 2, okay? B equals 3, 4. C equals Cartesian product, yeah? Product. And A, B. This is returning a iterator, so we convert it to a list. Then what do we have? Then you give us C equals 1, 3, 1, 4, 2, 3, 2, 4. Okay? Simple as that. That's Cartesian product. Okay, so A Cartesian product B, is it equals to B Cartesian product A? Come on, that's one question.
No.
No, right? It's not definitely not. Look, because look, 1, 3, 1, 4, 2, 3, 2, 4. And how about B Cartesian product A?
3, 1, 3, 2.
4, 1, 4, 2. Definitely not. Right? Okay, that's very good. So how about the cardinality? Cardinality, what's this word? Cardinality. I don't know how to spell it. Cardinality. This is basically the number of these elements in the Cartesian product. So look, there are 2 elements here, and there are 2 elements here. So what's the number of elements in the Cartesian product?
They are 4.
Okay, so how about 1, 2, 3, 4, 5? How many in the Cartesian product? There are 2 here, there are 3 here. So how many altogether? Cartesian product?
6.
Yeah, so you get it, right? So we use these to mean the length of the cardinality, yeah? So A Cartesian product B is equals to A times B, simple as that, right? We get the cardinality of the A and cardinality of B, and then we multiply it together. That's the total number of these elements in the product. We mentioned about the graph algorithm, the shortest path. Remember the shortest path algorithm? In the directed weighted graph, we can use the uniform cost search. Yeah, we mentioned that. We talked about that a long time ago. If it's an undirected and unweighted graph, we can use the breadth search, and we can also use Dijkstra. Okay, I don't know how to pronounce it. Dijkstra. We're going to talk about that in the next few days. Dijkstra. Okay. We also talk about this flawed algorithm.
Why are you getting Dijkstra? There's no I, so you can't say K.
Okay, it's a name.
Dijkstra.
A Dijkstra. Okay. Flawed wash. Yeah.
Why don't you say with J?
Okay, I don't know. We talk about that shortest path algorithm. Okay. So I, J, and there's a K. Right? If the cost between B to I plus I to J is shorter than I to J, then we can replace the cost from I to J with these shorter paths, right? So for example, look, I have another very complex graph. I'm going to compute the minimum shortest path from A to B, right? Look, A to B. I found out like I to J the cost may be 100, and then later I found out that I to K is 50, K to J is 20. So how can we improve the shortest path between A to B? My current shortest path from A to B is through this path, right? Look, it's through this path. Yeah, I don't know. Now I found out that I to K is 50, K to J is 20.
You go on the above.
I can replace the I to J with this shorter path, right? Because 50 plus 20 is smaller than 100. So I can replace this path from here. So it will provide us the shorter path, right? That's the spirit of this algorithm. Okay? So it's basically like a dynamic programming. So for K in range, it's the time complexity is OV cubic, yeah, n, and then for I in range n, for J in range n, right? And then we can say, look, if the shortest path dij, yeah, is the minimum. We want to get the minimum dij, get and then d I to K plus d K to J, right? So that's the spirit, right? I to J, and we found out that the K, right? So if the I to J, the cost is bigger than I to K and plus K to J, then we can replace I to J using these paths, right? That's what it is. For K to N, that takes N iteration, and each iteration takes N iteration, and for each iteration takes N iteration, so that time complexity is O n cubic, okay? So, but this one, yeah, look, this is IJ, yeah, this is the tuple, right? So we can use the Cartesian product. So look, because look, this is the same, yeah, this is the same. So basically we can replace this one for K, I, J in product, yeah, we can use this syntax. Product what? Product range n, and then we pass the second parameter, repeat equal 3 times, okay? Look, so these 3 for loops can be replaced by this one for loop, and this is the time complexity still O n cubic. For Kij, right? Kij, that's a tuple. Basically, this range n Cartesian product itself 3 times. That's what it means. Okay. So Cartesian product can be done in multiple sets. A Cartesian product B, Cartesian product C, Cartesian product D. A, B, C, D, right? Then A is belongs to A, B is belongs to B, C is belongs to C, D is belongs to D. Okay, that's what it means. So 1, 2, 3, 4, 5, 6. The Cartesian product will be what? Can you guess? Look, if the A is 1, 2, B is 3, 4, C is 5, 6. So what's the Cartesian product? If there are 3 sets, can you guess?
It is 1.
Yeah.
Is it like 1, 3?
1, 3, what? You need to take 1 from each set. 1, 3, 5. Yeah.
1, 3, 6.
Yeah.
1, 4, 5. 1, 4, 6. 2, 3, 5. 2, 3, 6. 2, 4, 5. 2, 4, 6.
You got it? Yeah? Okay, so that's the beauty of the Cartesian product. We can replace this. Right, look. On2, on cubic by this. Right? Tuple in Python. Yeah. Okay. And that's the shortest path. Yeah, we talk about this algorithm. Any questions today? What have you learned today? That's it.
About math.
Okay, so what's this? What have you learned?
Product.
Come on.
Cartesian product.
Cartesian product. Okay, Cartesian product. Right. So okay, so can you tell me, A, if it's an empty set, yeah, A Cartesian product empty in mathematics using this, yeah. A Cartesian product empty. What do we get?
Empty.
Yeah. So it's equals to empty Cartesian product A. But generally, A Cartesian product B is not equal to B Cartesian product A. Okay, we talk about that. Okay. Yeah.
Because it's opposite. Because it will be
B would be the opposite.
Yeah, that'll be for today. Bye bye.
Bye-bye.
Bye bye.